All right, today we're going to start chapter 6, finishing up the polynomials. We're going to get into rational exponents as well as radicals for this chapter. Hopefully you're going to see that it's an extension of what we have been doing up to this point. Again, everything that I try to do in class is trying to build off things that we already know or ideas that we've already talked about. So the chapter we just got done, chapter 5, we actually built polynomials. We talked about roots a lot. You're going to see the idea of roots coming into play again today. We're going to look at things a little bit differently, though. In this case, we're going to be square rooting things instead of cubing and taking things to the fourth power. So key ideas is definitely make sure you're okay with the idea of what a fractional exponent is and how it works. Some general properties that you need to know, just like in the polynomial chapters, we talked about the difference between even and odd, and they had different end behaviors when we graph them. The same thing is going to hold true here when we're looking at rooting things. So far up to this point, you guys mathematically have square rooted things. For example, the square root of 9 is 3 or negative 3. We're also going to get into cube rooting things, fourth rooting things, fifth rooting things, sixth rooting things. It just means instead of a pair of something, we need 3 of something to pull it out, or we need 4 of something to pull it out. And we're going to break those down a little bit too. So as we move through here, make sure you're kind of tuned in with the idea. Biggest connection piece for this first slide, and as we move through here, is realizing that we cannot take an even numbered root of a negative. If we do, we have an imaginary root. We have no real roots. If we take the square root or a fourth root or a sixth root, or any even root of a positive number, we will have 2 solutions. And we saw that when we square rooted something like 3. Square root of 3 is, when we square root 3, we get plus or minus there. For odds, we actually also have the ability to root them, but we have a little bit different kind of behavior. If my rooter is an odd, I actually have a real root if I cube root, say, negative 8. The cube root of negative 8 will actually be negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So when we have odd roots, if a is negative, or the thing that we're rooting is negative, we're going to have one answer. Same thing if the thing that we're rooting is positive. In this case, the cube root of positive 8, that answer is just positive 2. We only have one root there. So with odds, when we're rooting, we only have, and we always will have that one real root. And when we're rooting evens, we either have no real roots or imaginary, or we have 2 roots. Okay? And I'll talk about what that fractional exponent does here in a sec. All right. Question, find the indicated real nth roots of a. The n is the rooter, the a is what's on the inside of what I call the radical. So the way that we'll write this is the cube root of negative 216. Okay? The cube root of negative 216. For letter B, I'll come back and work that in a sec. For letter B, it's actually saying the fourth root of 81. All right? So we're going to have to work each of these. Hopefully, before we move forward, you're thinking, hey, when I'm looking at the cube root of negative 216, I need to have 3 numbers of the same thing in order to pull one out on the outside, just like we did with square rooting, but we needed 2 with square roots. For the fourth root of 81, we actually are going to need 4 of something to pull one out, and that should fit with what we talk about with our rooting. So let's look at the cube root of negative 216. That one, I believe, we can take out. We're just going to make a factor tree here. And I'm going to make that negative 6 times 36. I happen to know that negative 6 goes in there evenly. And then at this point, you guys would probably be tempted to break 36 down as to 6 and 6. Now the catch is, if you break down 36 to 6 and 6, I don't have 3 of the same thing to pull 1 on the outside. However, I do know that negative 6 times negative 6 is also positive 36. So the cube root of negative 216, and notice we have 1 to 3 terms here. I'll pull one of them out because my rooter is 3. So the cube root of negative 216 is negative 6. Something I'm going to talk about in just a second is the equivalency, and this is going to be that idea of fractions as exponents. I want you to see that negative 216 to the 1/3 exponent is actually saying the cube root of negative 216. Okay? So again, negative 216 to the 1/3 is the same thing as saying the cube root of negative 216. These two things are equivalent expressions, and those two things also equal negative 6. They say the same thing. Another way to look at that fractional exponent is to say, hey, that's negative 216. When I'm looking at a fractional exponent, the bottom is the root, the top, or the numerator, is actually the exponent part. So another way that you can see the negative 216 to the 1/3 exponent is to say the cube root of negative 216 to the 1 exponent. And again, that's going to come into play later. So just make sure you're okay with really what this fractional exponent is saying and how it relates to the original problem that we were simplifying. Okay? So fractional exponents, the bottom, the denominator part of the fractional exponent is the thing that you're rooting by. The top part will be an exponent, and that'll come into play in just a little bit. I think the basics here is pretty straightforward, though. Just the cube root of negative 216 is negative 6. Let's go ahead and move over to letter B. Letter B is the 4th root of 81. We're going to break that one down to 9 times 9. 81 is 9 times 9. We're going to go ahead and break the 9 down to 3 times 3, and then 3 times 3 again. 3 times 3, and 3 times 3. And at this point, since we have to the 4th exponent, we realize that we actually need 4 of something. 1, 2, 3, 4. We would have to pull out one of those now. And remember, it's saying the 4th root of 81. In this case, we have 2 possible solutions. Notice that this is an even numbered root, so we have 2 possibles, plus or minus 3. Those are our 2 roots there. Make sure you see the difference between letter B and letter A. Letter A was a cube root. That was an odd root. An odd root, we're going to have 1 solution. An even root, 2 solutions. Okay? Writing the 4th root of 81 as a fractional exponent, just to make sure you're okay with that, that would be 81 to the 1/4. Again, remember that the denominator is the rooter and the top part's the exponent. Okay? 81 to the 1/4 is the same thing as saying the 4th root of 81. Those two things are equivalent expressions. Oh me, oh my, it looks like they're talking about fractional exponents. I am shocked to see that they're talking about fractional exponents right now. It's almost as new as if I knew that this slide was coming up. So, fractional exponents, I think the letters is a little bit confusing. Take what I showed you over here, and we will apply it on the next problem. Big thing I want to remind you of, negative exponents means that exponent is in the wrong part of the fraction. To make an exponent positive, we move it to the other location in the fraction. If it's in the denominator, we move it up and make it positive. If it's in the numerator, we move it down to the denominator to make it positive. So negative exponents will come into play again. I will explain what this jibber-jabber means in a second. Again, make sure you know that the denominator is the rooter, and then that numerator in the fraction is actually the exponent part. Okay? Part A, evaluate 16 to the 3/2. Part A is saying 16 to the 3/2 exponent. Remember that the denominator is the rooter and the numerator there is the exponent. I have 2 ways that I can write this. Both are equally correct. One is the square root of 16 cubed. That is one way, and that's correct. Or I can write it as the square root of 16 cubed. The exponent can go either out of the parentheses or inside the radical. Either are correct. My advice is to use the one that makes the most sense and simplifies down the easiest. In this case, I would go with the one on the left. That's this one here, because I know that the square root of 16 is really easy for me to do. The square root of 16 is 4, and then we will need to cube 4. So 4 cubed is 4 times 4 times 4, which in this case is 64. If you want to see it the other way, to show you that they do match up, they do equal the same thing, we're looking at the square root of 16 times 16 times 16. I'll break all those down to 4 times 4 and 4 times 4. It's a square root, so I need a pair of something. At this point, I would have a pair of 4s. One 4 goes on the outside. I have a pair of 4s. Another 4 goes on the outside. A pair of 4s. And another 4 goes on the outside. And I have nothing left on the inside. So the answer is going to be 4 times 4 times 4, which is, again, 64. Both of those work either way. I like that middle one or the left one there. Kind of easier. Both work. Realize that that will get you the same answer. All right, letter B. I'm just going to do that on the next page here. 32 to the negative 3/5. You should recognize that that is a fractional exponent. And you should also realize that that is a negative exponent. So we've got two things we have to deal with in this case. The first thing is we've got to get the negative into a positive that's in the wrong location. So we move that down to my denominator. Get a placeholder up there for that 1. So that's 32 to the 3/5. Now I'm going to just work on the denominator, which is 32 to the 3/5. Hopefully at this point you are agreeing with me that that's the 5th root of 32 cubed, or the 5th root of 32 cubed. Either work. And the way that I'm going to look at it like this, I'll go ahead and take, again, like I said, they both work. This one's a little bit easier for me to do. So let's break down the 5th root of 32, and then we're going to cube it. 32, I know, breaks down to 16 times 2, which I know is 4 times 4, which is 2 times 2, and 2 times 2. Again, I need to take 5 of something in order to get one of them out. This is the 5th root. 1, 2, 3, 4, 5. I take one of those 2's out. There's nothing left on the inside of that radical, so the answer is 2 cubed, which in this case is 8. So the whole answer to this problem, remember, we had to fix or simplify. 32 to the 3/5. 32 to the 3/5 simplifies to 8. So the answer to this problem, or 32 to the negative 3/5, is really just 1/8. All right, next up, using your calculator. I'll show you to use your calculator in a second to estimate. Calculator has nice buttons for these. All right, that's going to be you guys. We don't have any calculators to do. I'll do one calculator expression for you. Actually, I'll do all of these. They do tell you the nice keystrokes here. Many of your guys' calculators have this button. That button raises it to the exponent for you. Make sure when you're raising it to an exponent, you're getting the fraction, and you must have those parentheses up there. Otherwise, it won't input correctly. Some of you guys on your calculator have an X to the Y button. Your X to the Y button is the same button as the raising to an exponent button. Here's what it looks like in a calc. So you can see the calculator input. It would be, we're looking at 9 to the 1/5, so that is 9. Raised to, that's the little caret button. Parentheses, 1 divided by 5. Close your parentheses. and execute it, and you're going to get your answer. If you want to see calculator keystrokes, I'm going to do the next example right now. It'll look like this. Let me see if I can clear that. So the next one is going to look like, and I'm going to just give you the keystrokes here. That will be 12 raised, parentheses, to the 3 divided by 8. Close your parentheses, and then press enter again. And again, 12 to the 3/8. It'll give that decimal. Lastly, the last one that they asked us to do right here. This was the 4th root of 7 cubed. Hopefully you're agreeing with me right now that that actually says 7, and it's a fractional exponent. Remember, the rooter is the denominator, and the exponent is the exponent. So 7 to the 3/4, which hopefully this calculator input is now making sense to you. And again, that would look like this. 7 raised to the parentheses 3 divided by 4. Close your parentheses and hit enter. Okay? Pretty straightforward for that. That'll be you guys. And now solving. I think solving, if you've been following along with what I've been doing, I think solving is kind of the easy part here. Solve the equations. So we've got 4x to the 5th equal to 128. Here's the key to success for solving. It's very similar to the technique that we use for quadratic equations, which is solving by square rooting. And really today we're not square rooting these things. I'm just going to say we're solving by rooting. It's going to behave the same way as solving by square rooting. So we're going to get the exponent by itself, and that's the key. Exponent by itself. Then we root. And I'll show you what I mean by that. Okay? First one, 4x to the 5th equals 128. I need to get the exponent by itself. To do that, I will divide both sides by 4. When I divide both sides by 4, it's going to give me x to the 5th equals 128 divided by 4, which is 32. At this point, I want to get rid of the x to the 5th. So I'll root. The way that I get rid of x to the 5th is I will 5th root. I will 5th root both sides. Remember now, here's the key. If it's an odd numbered root, it's not plus or minus. I only have one real root. If it's an even numbered root, I will put my plus or minus sign. Just like when we solve by square rooting, when I square rooted something, that's an even numbered root, I put the plus or minus. In this case, this is an odd numbered root. It's the 5th root. I will not put the plus or minus. So that's all I have to do to solve this. So x, that's the 5th root of x to the 5th. X is going to equal the 5th root of 32. And now we need to break that down, which is 16 times 2, 4 times 4, 2 times 2, and 2 times 2. By the way, you probably have already figured out that the 5th root of 32 will be 2. 1, 2, 3, 4, and 5. So in this case, 4x to the 5th equals 128. My answer is x equals 2. And you plug that back in and make sure it works. 2 to the 5th is 32. 32 times 4 is 128. So it checks. Letter B. I'm going to show you something here. X minus 3 to the 4th equals 21. At this point, our first step is to get the exponent by itself. The exponent is by itself on this problem. The x minus 3 is both to the 4th. So now I'm going to root both sides. And there's the 4th root there. And there's the 4th root there. Now, this is an even numbered root. Because it's an even numbered root, I have two possible real roots. So I need to put the plus or minus. I did not put it in letter A because that's an odd. I need to put it in letter B because it's even. On the left-hand side, the fourth root of x minus 3 to the fourth is going to be just x minus 3. On the right-hand side, I have this sexy beast that is plus or minus the fourth root of 21. You need to try and break down the fourth root of 21. The only thing that goes in 21 is 3 and 7. I can't split that any farther, so I will leave it as the fourth root of 21. Finish up this problem. I will add 3 to both sides, and I will leave my answer as x equals 3 plus or minus the fourth root of 21. And that is our answer. Okay, 2 roots there, 2 possibles, and that's all we need to do. You can use your calculator to estimate that. Should you use your calculator to estimate that? You don't need to. This is fine for me. But realize that there is 2 answers. One is 3 plus the fourth root of 21, and the other one is 3 minus the fourth root of 21. And you should be familiar with moving that across. We've seen it before, and now you can use your calculator. Should you have to do that earlier? One last little tidbit before we get to the next problem. I want to look at this letter B again. And I want to make sure that you guys, oops. I want to do that, sorry. I want to look at this letter B again. And see if you can follow along, or hopefully you'll agree with what I do right now. I have x minus 3 raised to the 4th. You told me, hey, we're going to solve this by rooting, so I'm going to take the fourth root of both sides, and that's indeed correct. Here's what I want you to make sure that you're okay with. Me taking or raising both sides of that equation to the 1/4 exponent. If I raise both sides to the 1/4 exponent, that is doing the exact same thing as fourth rooting. Notice that the left-hand side, these 4's will cancel, and I'll have x minus 3. And on the right-hand side, it says 21 to the 1/4, which you should now know is the exact same thing as saying plus or minus the fourth root of 21. Notice that we get to the exact same thing. I just want to make sure that you guys can see that equivalency of fractional exponents matching with radical. Okay? Make sure you're okay with that connection. Notice that it's the same. All right, last problem. Word problem, biology. Studies determined that the weight in grams of a coral cod near the Palawan Island, Philippines, can be approximated by the model W, or that's weight, equals 0.0167 L cubed, where L is the length in the cod centimeters. It says estimate its length when it tells me its weight. If it weighs 200 grams, how long is that fish? Great. So it gave me an expression, W equals 0.0167 L cubed. It told me it weighs 200 grams. It weighs 200 grams. Oops. Oops again. And really, all it's asking for is the length. So I got to solve that equation for L. I'll be going in and out of the calculator with this one. First thing I'm going to do is divide both sides of this equation by 0.0167. So in my calculator, I'm going to put 200 divided by 0.0167. And it gives me that number right there. I'm just going to leave it. Next up, and I'm just going to say, since I'm doing this in my calculator, I have L cubed equals that number that's sitting in my calculator. Well, what do I need to do now to get L by itself? I'm going to raise it to the 1/3 exponent. Isn't raising to the 1/3 exponent the same thing as cube rooting that? Hopefully that idea makes sense with you. Raising to the 1/3 is the same as cube rooting. What I'm doing is getting rid of the exponent on the right-hand side. Getting rid of that exponent, so that gives me just L by itself. Remember, I have 200 divided by 0.0167 sitting in my calculator. There it is. And so what I'm going to do now is I want to take the cube root of that. The way that I'm going to take the cube root of that is I'm going to raise it to the 1/3 exponent. So if you have that on your calculator, you can press this button right now, which is your raising, and it will take the answer that you got from the previous problem and raise it to the 1 divided by 3 exponent, or taking the cube root. It's going to give you a decimal. It's a pretty big, 22.879. That is the estimate of how big that fish is. 22.879, and that is centimeters. So according to that equation, the length of that coral cod will be about, and we're going to call that an approximation, 2 wiggles. It's not equals, it's an approximation, about 22.879 centimeters. Okay? Using your calculator, cube root, make sure you're okay with the idea of fractional exponents and simplifying radicals. That's really what we're doing. And I think that's it. That'll be you guys. And we're done.